My name is Joe Stanzione. I am an associate professor of chemical engineering here at Rowan University. I also have the responsibility of being the graduate program chair for the chemical engineering department. So the Sustainable Materials Research Lab, or SMRL, or as my students and I like to call it, just SMRL for short, has the ability to look at materials and chemicals at the molecular level. So we have various instrumentation to do that. But then we also have instrumentation to go ahead and synthesize our own new and interesting molecules that we think will help us with giving us a balance of properties that we desire for a particular material for certain applications. Our approach, like other people as well, has focused on the structural property relationships, on being able to build various types of polymeric materials and composites. Materials have this chemical structure makeup, and depending on how you build those structures up from a molecular level, or what those actual molecules are that you're using as your building blocks, it greatly influences or relates to the actual properties of the material that you build. And so those properties could be anywhere from something that is related to temperature. So what type of behavior does it have with respect to the environmental temperature that it's exposed to? Or it could also be related to its mechanical type of properties, like its tensile properties, or how much can you actually bend and flex it, or how much can you pull on it before it actually fractures or breaks. And so this chemical structures of these materials that we build definitely influences those properties. Recycling has become, it seems like recently, a much higher topic with respect to media coverage. And you've seen a lot of stories popping up about all the plastics that's in the ocean. It's really become at the forefront of that recycling topic, and the need has become, seems definitely become more drastic and necessary to be able to mitigate all of the environmental issues that we're seeing. We hope that what we are finding and discovering is leading to making what you can consider or call better materials, more specifically better polymers and composites. They have the actual properties that you want for the time that you want it, and then you can go ahead and return that material to essentially wherever it came from, and you could potentially reuse it again. And we are seeing it within my short stint so far as being a professor at Rowan University. I've seen more and more people from various industries and various fields actually wanting that in their materials. It's becoming more and more of a thing, and people value it more. Like, where do our things come from, and what happens to it when I'm done? I truly believe that being able to use renewable resources in the most effective way is paramount for the sustainment of life here on Earth. One of the benefits that the students have to being able to work in the Sustainable Materials Research Lab is that they get the opportunity to not just work together in teams working on projects, but they have the ability to work with our external collaborators. And these external collaborators are various types of institutions, ranging from other highly ranked universities to federal agencies, including government research labs, as well as industrial partners. It's greatly imperative to have the tools that we have in our lab. So being able to really trust the data that we're getting from our instruments is very critical, mainly because that helps us to really fully characterize and understand at a fundamental level what we're actually making. Just in my short lifetime here at Rowan, I've seen it grow exponentially, and not just with the number of people that are here, but also the infrastructure. And what I like to say to people whenever I talk to them about Rowan, even if they know Rowan already, or if they don't know Rowan already, I like to say the phrase that Rowan's growing, and it truly is. And it's remarkable to actually see and to also be a part of that growth.